The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people are evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Hello everybody, how you doing tonight? My name is Philip Ong, I'm a geologist. I'm here with Mr. Dane DuPont. We're coming to you on behalf of Hawaii Tracker, hawaiitracker.com. And we're going to be sharing with you tonight some of the more recent developments on the 2021 Kīlauea summit eruption that began 1 month ago, December 20th, 2020. And today, January 20th, 2021, we're going to kind of recap the last month of the eruption as well as those recent changes for you guys here. So let's start off by showing you guys a series of 3 videos here, and something mentioned before I maybe get all the way going that Dane's going to be manning the chats and collecting questions from you guys to first answer at some point in our broadcast. And so let us know if there's something particular we can address for you guys, or that's not clear, or that you want us to say again. So all good. All right, so we'll start you guys off with 3 videos here released by the USGS, and this one is the more recent one from 2 days ago on Monday. And this is a video showing the recent change in the west vent configuration. So let me play it here for you guys, and let's see if this is going. It seems like I'm having some kind of... Let's see if the video will actually play for me here. No, it's not behaving. How am I doing, Dane? Am I coming through for you guys all right?
Seems okay so far.
All right. So, okay. So here's a video. You can see spattering coming out of that main vent. That's that main west vent, and there's like a crusted over lava channel that's pouring down underneath the crust into the lake here down here below. And we also have this slightly to the north and east secondary vent that's opened up, and it also has a now open channel that's going down to the southeast. So we'll let it go through a little bit. Let me maybe rewind it here. Let me pause it and rewind it. And just so you guys can see here, I want to make sure I point out to you guys this bottom flow of lava coming out here at the bottom, pouring upon mainly this area, but there's also a lobe going off in this direction over here. It's kind of hidden a little bit from view, but you can kind of see there's the exit of that stream from that cone, right? And so that's happening on both sides, although over here it's more crusted over, the crust isn't moving as much. So they're focusing on events here. There's actually a third vent. When you look more closely, that's up here, that's kind of glowing. When the first pulse of gas came out, this one was spattering quite a bit and just dropping little lava pellets out of here outside the spatter that's forming the edifice, the structure of that cone over there. So that was January 18th. And let's go back in time a few days here to January 15th. And actually, since that last update we gave you guys and that secondary event opened up, it's since closed off again and started up again briefly and then closed off again. So maybe what I can show you guys is, if my videos will play here. It seems they're having trouble playing the video a little bit. Here we go. Yeah, you can see this low fountaining action happening here, and it's dropping down through this channel, kind of gushing. Right? You can kind of see there's a little bit more pulsing in the lava crust here at the bottom. Maybe you can see that. I'll point it out to you guys, and kind of more vigorous and more gas and more lava coming out in general here. And that's something we've also seen, is that the pressure has gone down in the last day kind of dramatically. Still in a small scale compared to the main scale of the eruption, but it might be more of this kind of cycling that we're seeing on a larger scale than we've seen thus far on the eruption. So this is what it looks like more like now, that where the secondary vent on the side is closed off once again, and it is occasionally spewing out again, and of course it's filling in that low trench that exists below that rim of the perched pond over there. So that was the 15th, and we'll go back in time to the 12th, 3 more days, and show you guys a similar kind of view of that fountaining there. And there it is once again, that kind of open channel going down. Nothing happening over here at that point in time, although there had been a brief opening that happened earlier there. So that's that third video that's been posted by the USGS Hawaiian Volcano Observatory, who are providing all this footage and image courtesy for the public education, public good here. So we're just trying to give you guys a little bit more detail and a little bit more coverage, and point out some of the details that a geologist might notice that maybe you guys might also notice, but you'd like to have someone back you up on it. So that is January 12th. And so let's look here just at the last few days. And so kind of see here that secondary event opens up in a thermal camera, and it's pouring into the side through those various channels, and it stays active for a while. It kind of focuses on this little section over here, bursts out more over here, there's some crust, and then it kind of dies off. And it stops for a little while, it's still glowing, it's still red, it starts back up again. And in the meantime, this other source does seem to continue persistently. That main west vent seems to be still the most dominant, active, easiest place for lava to get out. It seems like when there's a little bit more pulse or more gas, or comes up a slightly different way, it seems to come out the side over here. So that's interesting to see, right? So I can play that one again so you guys can see from the beginning a little bit how that actually goes. And you can also notice here that there's circulation around the island, right, kind of on the surface, and this whole back half is no longer resurfacing itself. It's all one big solid chunk. And you do see occasional breakouts from the edge over here where lava comes up, right? But it seems like it's lifting up that entire crust, the perched rim of it, the islands, the crust in it, all as one giant block, and it's squeezing out that outer edge over there next to the crater wall. In fact, it's not squeezing up on the edge of this perched pond, doesn't seem as much, although maybe it could be coming up on the edge through a little lava tube and then popping up on the edge over there. That's another possibility. But it appears like, and I'll show you guys more evidence shortly, that this whole thing is lifting up as a big unit as lava is filling in below it over there. If I play this again, it's kind of subtle, but the island that's supposedly stationary, according to USGS reports, does seem to wiggle a little bit. It does very slightly move, and that'll be more obvious when I show you guys some of these more zoomed in pictures. But it's not moving very much. It is moving a little bit. You can kind of see that a lot of this perched edge over here is getting filled in by that recent lava flow. Right, and then we also have our inactive north vent island, maybe we'll call it, because it's no longer where the north vent began. As I showed you guys last time, and I repeat it today. This thing's been moved. That C-shaped pile of rock that was the spatter, the frothy stuff that landed around the hole that when lava first came out of there has been picked up by the rising tide of the crust and the lava underneath it as well. So let's show you guys some of that in a little bit more detail. And let's skip no, well, I'll show you guys this view here for now too. So this is the S1 camera, and this is a time lapse that we put together for you guys. The S1 camera is on a USGS website. It is not generating automatic time lapses right now, so we'll try to put this together for you guys so you can kind of keep up with what's happening here. And this one's kind of focused in. I'm going to kind of start from way zoomed in and kind of zoom out on it. So we're zoomed in here on our most active west vent, and we're starting on the 13th. So this is before that changeover, that side vent. You can kind of see it's glowing over here. It had actually put out a couple early flows last week. And so you might see some action here at the very beginning of it as I play this through. Kind of a little bit burst out there. It does appear kind of washed out at night, but you know, kind of see that circulation in the daytime. You can kind of see where the sources are, right? And still clearly only one source at nighttime. Until that opens up here. First little burst on the 15th, 16th. And here comes the next one on the 18th. 17th to the 18th. There it is. Putting out that big channel, pouring in that way, and then a little slight diminishing of that west vent, but it kind of kept going underneath the crust and just picked back up once that side vent shut off once again. So here it is, shut off on the 19th, and so we're almost to today. It actually shut off. It restarted last night, poured more into the lake over here, and then shut off again by this afternoon. So that's the current status of how that looks now. And so let's zoom out on that and show you guys, not that one, but this one. And so that whole area was happening over here. Zone over here. And so now you can kind of see the larger circulation where the lava is moving around on the island, around the island over here on the side. Kind of mostly circulating in this near area, this most western part of the lava lake where the lava is filling in that hole. And maybe that's why it's pushing this island slightly this way, right? But there are these occasional flows coming around the backside, repaving it. This whole backside of the crust, when I zoom out, you'll see more of that direction. So for now, we're just going to looking at where the lava does appear to be moving on the surface, and it is still going around the island, actually going all the way around. And so that's resurfacing. At least this section is still all resurfacing. Somewhere to around in there is the edge of the resurfacing of this feature here. So while the actual area that's exposed to the atmosphere has been closing in, it's still liquid underneath that entire skin all the way across, right? That's kind of one thing to be clear. It's just kind of how it actually looks. And some of you guys have asked questions, you know, over the last few weeks as we've been covering this event, what might happen if it stops and as it cools and that kind of thing. And so that's kind of a little bit of the process of it, is seeing it close in on one of the sides, but still staying liquid underneath, because it loses most of its heat upwards to the atmosphere, where it can blow away the most easily, rather than through the rock, where it can still take away heat, but it's much more slow, a much longer process for that to happen. So here's the actual full S1 camera time-lapse view, and so you can kind of see there's this whole eastern side of the island, or of the crater over here, that has a solid crust that's fuming and only has occasional lava breakouts on the very edge, right along in there. Maybe you see some of those at night, maybe in here as well. But otherwise, the crust is not moving. We do still see some of this remains of that north vent over here. You kind of don't see as much of it on a back wall anymore of the crater, because you can kind of imagine that as this island is lifting up a little bit, it's starting to rise above the stuff that's still plastered on the wall. And so that's kind of an interesting thing to look at, is that this lava on the wall was the highest spatter of that initial north vent, and then now that rafted stuff has been picked up, is getting that same elevation apparently, or higher already. So this is going to get covered by the rising flows, while this initial part of the lava will be preserved, right? So at some point you could go down there and sample the lava, for example. You could actually sample some of this stuff as the more primitive first lava that came out compared to some of the later lava that came out, which is forming the material of this cone over here. And it might be an interesting thing to study if someone can ever get down there, if this thing ever stops. So, all right, that's the zoomed out view. And so we will do these thermals as well, but first let's go to our deformation data here and just show you guys what the pressure looks like over the last day here. So let me zoom in a little bit so you guys can see a little better. And I will change my color to a easier to see red here. And on our left side of our graph over here, we have microradians. That's a tilt of the ground. And it doesn't exactly, you know, we've told you guys before what that actually corresponds to, but, you know, in the end, you can kind of just, you know that the scale can vary a whole lot or a whole little. And here we're going from 3 to -5. And so we have an 8 microradian span as the actual span of this particular graph. And so we start off here about 24 hours ago, somewhere around a +2. And if we scroll to the right over here, we end the day over here, not quite to that last tick mark, but almost down there to the -4. So from 2 to -3.5, 5.5 microradians we've dropped in the past, well, it looks like maybe 18 hours or so, something like that. And that, if we go back to the last week, you can see it here. There's a big drop off right there, and it's still going. It seems to be shallowing out a little bit, but it might actually go a little bit more downwards before it shallows out. And that follows a period of several days of more or less stable, right? You know, it was slightly increasing, and kind of if we zoom back a little bit here, you can see our increase coming up with a kind of cycling up and down, which I believe might be something to do with the gas movement, gas pistoning, something along those lines. Right? And then a slow rise, and then somewhere in here it kind of flattens off, although it's still slowly rising. It was kind of not clear if it was just kind of doing a wiggle or what exactly was going on in there. And then it came into this much bigger drop off, right? So that's the last week. And so you can kind of see that whatever we gained over the last week, we've already lost more than that here. But let's zoom out a little bit more for the past month. And now that we've crossed the 1 month mark, we actually have here, we've gone off the chart. Our plot starts off something like this and comes all the way down. And so this drop over here was something like 45 microradians that occurred at the beginning of the eruption over those first 5 days. And then since then, we come back up a little bit. And that was because of the switch from the north vent to the west vent. And then once that stabilized, we had a kind of decrease in pressure. We saw this big, apparently it looked like a deflation pulse, and we thought at the time it might be a deflation-inflation cycle. And it turns out that maybe it is, because, you know, the size, the length of this deflation was one that we were saying didn't seem like it was extraordinarily long compared to our typical cycles that we've seen. But maybe things are different with an open vent. And it looks like we might have a similar kind of thing happening over here, possibly a little bit bigger. It's already a bigger scale than when it happened back on between the 6th and the 7th and the 8th. So, but it could essentially shallow back out and then come back up again, and it could do that kind of cycling, where it's been speculated that that's something like the denser magma moving down through some narrow conduit, right? And that kind of blocks the path of the more buoyant gas upwards. So the whole thing kind of deflates. And then once that moves into an area that has a little bit wider opening and can move out of the way, then that fresher, hotter magma can then refill that area and then come back up, and it can re-inflate. And then you could have a more gassy, you know, a little bit like a surge, a pulse in eruption, so to speak. You know, and we may have seen that with that low fountaining. So it'd be interesting to see now that we're seeing this drop off on the tilt meter and the pressure here, whether we'll see a drop in the fountaining. In fact, we have seen that secondary vent shut off, and maybe that has to do with it. It's hard to tell because it was on and off and on and off again. It might have more to do with the secondary gas pistoning effect that's going on over here, rather than anything else, you know. But we may see a change in that from low fountaining back to that Strombolian poof. Once in a while, you get a spatter burst of lava coming out, like a firework almost, right? Rather than that continuous low jetting, it's just bubbling, 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 bubbling. And that's just kind of as gas is working its way out through all the different conduits and different sizes of them, right? And so it's worth mentioning again that we think that where it's been published by Matt Patrick and all the other HVO associates, that following up on the connection of Pu'o'o and the summit of Kīlauea, following the 2018 eruption, that they look back on their data and they believe that the conduit, the connection between those two areas was on average 2 meters, 6 feet or so, all the way. Right? So we're not talking about massive caverns, but rather different pipeways. You might have one that's that size, you might have a second one, and depending on how much is moving and how fast and what the pressure is doing, you might have multiple pathways, and that's where it gets kind of beyond a resolution and tricky and detailed and hard to really figure out what's going on. So, but that's the kind of thing that we consider as we consider the process happening underground and why we might see a signal drop like this all of a sudden, right? It's the same kind of pattern we saw here. And so maybe we're having a much longer deflation-inflation cycle that's lasting in an order of weeks now, rather in an order of in the past, a few days. And of course, the scale of this is all still tiny compared to the big drop we had off at the beginning of the eruption here. So overall, it's been a big decline with some small variations. And this was the biggest interesting thing here. What did this mean? This big increase, and now that it's followed by another downward pulse, you might suspect that it's just this might be like a batch, right? A little batch of magma that came up, and then now we have another batch of denser magma going back down, and we might have another batch coming back up. And so this might be, kind of, that's the interesting thing is, how often, how many batches can it keep putting up, and how often, and at some point, will you close off the conduit, right? And so for some of you guys who haven't been following Kīlauea for as long as we have, there were times during a Pu'u'u eruption when a deflation-inflation cycle would actually shut off the flow of lava from Pu'u'u vent, because it would last for several days where the vents could actually close up and close those pathways. So that's how quickly it can all congeal almost, so to speak, right? And that's why that pressure is so interesting there. So that's the past month there. And so if we look at the GPS, this is a line across the summit caldera of the volcano. You can kind of see that over the last year, it's been slowly generally spreading, right? Increasing as the distance between the north and the south gets farther and farther away. And as eruption kind of accelerated here, we had an intrusion in early December, didn't actually reach the surface. Essentially, it was a small failed eruption, but that didn't relieve any of the pressure. Obviously, there was a lot more pressure to relieve, and we now can say in hindsight, right, that it just picked up that rapid pace, and then here's where the pressure got relieved downwards, where the sides came back together again as the pimple got popped, so to speak, as the lava burst out and expelled that massive amount of gas, especially over those first few days of eruption. And you can kind of see that as that west vent became the more dominant one, we actually had to bounce back up, and it kind of dropped back down, and see we actually been going back up recently, and then maybe it's flattening off here. So this is the question here, is that this is that same batch coming up here, is how long do these batches last? If they're going on this long, they're going to show up on a GPS as well, like this. So we'll see how that actually goes. And for the last 5 years, in comparison, this 2020-2021 event is very tiny compared to what happened in 2018. And we'll leave it at that for the tilt data. And so we'll see what we can experience here with our eyes, and a few more pictures here. This is changes in vent configuration. So similar kind of imagery as we showed you guys the videos here. Here's that vent putting out lava on that north and east side of the west vent complex, right? And this one is putting out lava also, and it's flowing more silvery here. This part looks a little darker, like it might be more solid. You see these little chunks of small islands in there that maybe are pieces of this. It's hard to say exactly, but some of the chunks from here that we've seen collapsing could easily get flushed out and become some of these pieces over here. That's that'd be my prime suspect for where these came from. All here right in front of the vent. They have kind of been caught in the swirling eddies of lava that occur in here. All right, so that's January 17th. Kind of close up. We've seen that in the video. And they want to just also show a close up the southwest part of the lava lake. So that west vent is somewhere up here in the top right, and can just point out there's still that kind of active elevated crust over here. And especially on this side, it's still spilling over and making flows that are flowing to that trench over there. And this over here is kind of the side of that vent, it appears right there. So there's still that kind of perched edge right over there, especially on that west side and the southwest side of the crater over there, even if on the east side it doesn't appear to be quite that much. So, and then we have here those last couple of videos that we showed you guys the 15th and the 12th as well on that page. And so on a picture from last night, you can see here, the part that's incandescent. It's the same kind of pattern, that same main west vent, and here it is flowing around the island on both sides. So I won't belabor that image, but you can kind of see a little bit here. There is lava coming out. It's hard to tell from here from imagery whether it's spilling over that crust over there or if it's popping up from the side right there. That's something that'd be interesting to see. If you look on this side over here, all the way on the right, it does appear more like the lava is red coming up, almost like it's coming underneath all that way like that. I don't see anything red exposed over here. And although there could be possibly that little flow coming up and under, I suspect it's, at this point, seeing the time-lapse imagery, maybe I can convince you guys that maybe it's squeezing up out of that other edge, and this whole thing, this flat part, this rise, and this flat part is all rising up like a giant pancake all together. So we'll see if that turns out to be true or not. The last image here is we're pointing out a series of images from around 5:30 last night, where if I zoom in here, you're gonna look closely at the shape of this funnel here. It's kind of closed and narrow in that center part right in there, and that's the part that collapses. So you can see it here at 5:46. A big chunk is falling in, and it's maybe been undercut by the lava, and maybe that's why it's falling off. You can kind of see it slowly falling off piece by piece, right? They estimate that the height from here to here is somewhere in the order of 35 meters, so over 100 feet. Right, so this is a big piece of rock that's fallen off here. Right, I'm talking about it might be 30, 50 feet long, something like that. And then the final image here, when it's kind of all the way out of there, and we have a much wider channel pouring out of that vent over there. All right, so kind of minor changes happening around events nowadays, but that's what we're dealing with there. And so kind of let's focus on a time lapse here, and I've put together this kind of 10-second loop for you guys, kind of just showing for the last 10 days or so, zoomed in on the thermal of that west vent complex. And so there's I'm going to change my color here so you guys can see. You can see there's that west vent right there. The side vent shows up on this side over here, and it puts lava out. There it is. You can see it pours into the lava pond there and there. Otherwise, our main plunge source is over here. You see the lava's radiating outwards that way, and also that way. You can see our island is up here. You can see the edge of it kind of moving away, and so this is something to keep an eye on. During this loop, you can kind of see that the island is actually moving away from the field of view here, right? And there's kind of two explanations. One is it could be moving sideways, being pushed by that current, and the other thing is it also could be rising upwards, towards the camera as well, or upwards and away from the camera a little bit as well. And that's kind of hard to discern from this point of view. But we do, expect it as rising with the tide, so to speak, right? And maybe these is where that chunks of that cone are falling in and making these little floater islands happening over there. It's interesting to note the edge of the island moving upwards there, and then the change in event, how this thing starts off kind of small and grows to the side, and then it bursts out the side and takes over. That's kind of been the story of this, what this batch, this pulse of magma has done here to the crater, and to the way that the vent looks and how it's come out. Because before that, it was bursting out like occasional spatter, while also just oozing out the bottom. And then we had that dome fountain that was occurring because the pressure wasn't enough to shoot it in the air. It was all just flowing under the crust and kind of bubbling up from there. And so that's the kind of zoom in version there. And so let's look at a few other features we can zoom in on here. So here's another loop for the last 10 days, and now we're going to look at that south and east, right? South over here and east over here, part of this crater. And here's our inactive north vent, and we'll look at that next. But you can kind of see here, what to focus on is this edge of the crater over here. You can kind of see the lava is kind of squeezing up all the way around there and oozing to the side. There's some spots, like there's a white streak up here that doesn't move. And it's hard to tell, probably for you guys, if you're looking, especially if you're looking at a smaller screen, how these parts don't move. But you can kind of see on a loop here, this 2-second loop, that this whole crust right here, if you look at this whole area, is all rising upwards, right? And when you look, you can kind of see this thing is also rising upwards. When you look closely here at the beginning, it looks like lava actually floods into here and covers it up. Right? So this is almost below the lava, and then it actually rises out of the lava over here. We'll look at that a little closer as well. Maybe you can kind of see here, if you look at this edge over here, how the island is wiggling. And if I put the whole last 10 days into 2 seconds, you can see that there is some movement there, yeah, away from the camera. Right, and certainly a lot of other things move as well. And then of course, we still had at the very beginning a little bit of crust overturning, and that's what we don't see as much anymore over here. Right, when it kind of turns a little bit brighter pink in here in these areas, right? So, but certainly that whole area is rising upwards there and there and there. And so when I zoom into this area, it's a little bit dark and hard to see and pixelate, but let's try that and see what I can show you guys here. Because that is our north vent. It's kind of this C-shaped mass right in here. Has these edges like that. And here's the actual outer crater wall. And at the very beginning, you can see we're touching here at the back. And the lava seems like it flows in and kind of around the sides, and maybe it's picking this thing up. And so I found it interesting to focus on this little wing tip of it right over here. It looks like lava actually covers all the way out, and it seems to rise out of the lava a little bit over here. And maybe there's some fume and other lava, and the lava is lapping up and over it from time to time. But maybe you guys can see through that grainy and darkness. Now this thing is clearly moving upwards with that tide as well. And that's something else we'll await USGS's initial comments on. I've not mentioned any of this stuff yet. So Dane, I think at this point we can work our way towards some questions. And yeah, while we do that, I will play off this kind of 15-second loop of the entire thermal of the eruption. So I'll let that play while we answer some questions.
Right. Before we get into the questions, just got to say that, we're brought to you today by Hawaii Tracker, hawaiitracker.com. Make sure to hit that like button and be able to share this stream. Really helps us out. We don't have the advertising budget of many areas, so and other media sources. So you're sharing the video and your likes actually help us, grow and maintain the channel. You become a user on hawaiitracker.com. Really it's like a social media site with works in a community-based format. And we're gonna dive right into some questions. We got some different ones today, and some more of the ones that we've kind of come accustomed to at this point. Mm-hmm. But let's talk about the vent feeding the lake. Question comes up about both the vent getting submerged, and is that still on the table, and what's the timetable look like for that? And we'll get into the different levels of escaping the crater, so to speak, the collapse pit from 2018. So like that 900 meter mark. And so you want to maybe go through some of that?
Yeah, we're going to do a bit more on the gas here shortly, but kind of the long and short of it is that the eruption rate has gone down. And as the eruption rate's gone down, it's been hard to hit the moving target of what to use as a projection rate, how quickly it'll fill. So, we knew that was going to be the case at the time, so we kind of put that out as a warning at the time that we did it. And it was more just for fun, as a guess. At the current rate, the lava is still filling. It's been increasing by 1 or 2 meters a day during this increased pulse. It may level off here for a few days if we're going to have a drop off in the pressure of the volcano. It may also level off the lava lake growing. Not only that, it's been having to fill in the edges, but if it's not just filling the edges but lifting the whole crust up, then that gives it a whole bunch more space to keep rising and rising and rising and rising. And as I mentioned just recently, and that's put up just in their video, about 35 meters, over 100 and some feet to the top of that fountain of lava to where the lava is now. And so if it were to keep coming up 1 or 2 meters a day, which would mean, continued high rates like we've seen over the last week, let's say, then you're still looking at over a month of having to do that to get to that height of that vent to submerge it. So right. That's the first part. The second part is, we saw this north vent submerged, and the lava just came out a different part of the crack. And so there are probably other parts of this crack the lava can come out or can force its way out, even if it's just up the hill over here a little bit. It's going to be nearby. It's not going to be like miles and miles and miles away from here. It's going to be somewhere nearby, a few tens of yards from these areas, right? More than likely, or if it doesn't go there, it can go somewhere else. It's going to be somewhere still close by to the summit area.
Right. So if this Jessica asked from believe this was Facebook. If the eruption ends, and what happens to the lava lake? Will it cool and harden, or will it drain? And how long is that process?
All right, so let's see. Let me go back to over here, and I'm going to pull up this graphic, which is the graphic that I've kind of compiled from various USGS sources about what happened at Kīlauea. Kīlauea is a lava lake that ended up being 440 feet, 135 meters deep in the end, so we're way past that, but the same kind of pattern is what you expect. What ended up happening is they went back and they drilled repeatedly through the crust of the cooling lava lake to see how far they had to go to get to the actual melt. And in 1960, that was 22 feet. In 1962, that was 43 feet. In 1967, that was 87 feet, right, out of the 440. And the last time they did it was 1988, where they got down 240 feet down to get to the actual melt. And given that profile, they think that all the melt became solid at a temperature of around 1900 Fahrenheit, 1065 Celsius, and around 1995. So 36 years after the eruption actually happened, 36 years later. Right, so that's the pattern of how these things actually go, and you kind of see they've drawn here on the different colors: darker gray, lighter gray, kind of tannish, and orange. Right, this is what cooled first, was this outer rind, and so you do expect some cooling against the walls and against the floor of the crater. Right, and you expect it to be thickest at the top here, where you can lose all the heat upwards and outwards, where it can fly away, right, rather than radiate out through rocks, which are something we use to build our fireplaces with, because they stay warm for a long time and don't cool off quickly, right? So so that's what we expect to happen, right? A cooling crust, and it to be liquid in the middle until something disturbs it. In the case of Kīlauea, that stayed quiet for 36 years until it became all the way solid. And solid doesn't mean cold; it still steams there when it rains. Even when it doesn't rain, still can see steam if you go hiking down the Kīlauea crater, one of the most popular hikes in Hawaii Volcanoes National Park. So we expect something to disrupt that lava lake, that cooling core of it, before 36 years go by. Whether it's some other collapse or some other eruption or something's going to happen to, that little patch of lava could erupt out into the floor of that new crater, or you could, something weird could happen, but it's unlikely to go 36 years and not do anything at the summit after this happens. So this is kind of the stage one of it. And then Ricky
is calling that a literal hot pocket.
It is exactly a hot pocket, yeah. Too hot to bite into there.
So we got a little bit different question. We have not done this one before in this exact type of wording, but looking at the Pahala area and the earthquakes that we've had there. Mm-hmm. Question is about, will any kind of catastrophic event come about from that type of activity? The comment mentions Krakatoa type event. So they're kind of curious about that. Okay, so let's talk a little bit about that, right? So obviously the Pahala, if anyone who's just watching data signals online, who looks at the earthquakes or has earthquake apps or those kind of things, the most interesting thing happening for a while has been these earthquakes around the Pahala region at the Big Island, right? They're very deep. They're over 20 miles down, 34 kilometers down. That's kind of beneath all the volcanic plumbing of the island. So it's kind of at the bit, that's the bottom, the base of it, so to speak, where it kind of comes up at that deep level and works its way to Kīlauea, to Mauna Loa, and to Lauihi offshore over here, right? So that the earthquakes themselves are interesting, but they don't actually. That's kind of the deep pathway. Now there are surface features up here as well. There is a southwest rift zone of Kīlauea that mirrors Mauna Loa. Mauna Loa is the big mama over here on the side, right? And Kīlauea, when she grows on the side of Mauna Loa, only really has one shape she can be, and that's the same shape as Mauna Loa, really. So Kīlauea kind of inherits that from Mauna Loa, and so we do have that southwest rift, which at the surface is that Great Crack, is known as a Great Crack, it's a famous feature on the landscape of Earth. You can see it from the space station. So it's something that people have looked at, and people who study imagery, have seen that. What's kind of unusual about the Great Crack itself is that it's called a Great Crack and not the Great Rift Zone, right? Lava has come out of the Great Crack, and you kind of see here behind all these earthquakes on the surface here. Let me put my settings back to the last just one day. Just go back to the one day so we can a little less cluttered and see the background here, right? But there's that Great Crack that goes that way.
right? And lava has come out of it in times back in the 1800s, especially, maybe late post 1790 to early 1800s. A lot of lava came out the Southwest Rift area. But overall, the Southwest Rift is a lot less active than the Southeast Rift, and the fact that the ground is moving here as part of this, the south flank comes all the way to here, all the way. This whole area is moving to the south, and it does move without being catastrophic. We don't see evidence for big landslides offshore of Kīlauea. We do see them offshore Mauna Loa in the southwest, and we do see them other parts of other islands, but we don't see them on Kīlauea. Excuse me. Maybe partly because there's other topography to the south here, not just Lo'ihi volcano, but other seamounts that have been carried on the ocean crust that the Kīlauea hotspot is erupting through, right? So, if I can point out, let me zoom out here a little bit and point out just the shape of this, like the southwest rift of Kīlauea. Well, I'll see if I can draw any better than that. The southwest rift of Kīlauea comes with a pretty gentle arc like this, kind of down in the south from the summit. The summit caldera is right in there. The southeast rift zone starts off like this, and then does this massive bend over this way, like that. Right, and the reason it has this big hook here at the end is because, not because it started off that way. This started off being over here, and over here, and over here, right? But there's so much lava that's come out of this side that it's trying to push that way. It can't. It's trying to push, and it basically can go that way. So as the lava comes out of the rift zone has rotated and moved from being this shape to being this shape to being this shape to eventually be in this shape. Right, where now it actually, here's a current trace as this last line I'm drawing. It goes like that. Current shape of the East Rift Zone. So this hook tells us a lot about how much more active the East Rift Zone is in the Southwest Rift Zone. The Southwest Rift Zone is active, and it does actually see movement, right? It did see movement also following the big earthquake in Mauna Loa, 1868. And so if I'm in Lehu or Pahala area, I'm more worried about Mauna Loa's south flank than I am about Kilauea's south flank. And there's not so much danger of this thing collapsing over here, but it is going to be a big shaker, right? And that's kind of, where you are. The big landslides are happening over here. Right, and then you get with the locally generated quakes from Mauna Loa, you get those locally generated tsunamis, which instead of, the tsunamis that we're more accustomed to recently, where it happens in Chile or Alaska, and we have several hours before it gets here to make decisions, figure out how big it's going to be and all that types of stuff. With a locally generated earthquake, that water's, coming in real quick, like you got minutes. Right. And so it's all about the volume of water that's displaced, right? And so if it's like if it's a landslide, then usually you have some kind of limit of how much land can fall into the water. And often you worry more about something a submarine landslide, because that's the thing that could displace. All of it is displacing water. And then that's when you can really get, and that's why underwater fault lines are especially dangerous, because you can generate along, in a case of, Chile, you can generate along a 1,000 mile length of fault. You can move the water upwards, and then that's what causes trouble. All right. So I think I got one more for this. This round is talking about water interactions with the lava lake, and is there any, and what kind of interactions are there? I think at this point, where it seems like the water is probably in some kind of steady state. There is water being put out by the vent that's coming out dissolved from the lava, but that's probably not what you're talking about. Right? You're probably talking about the water that used to be there before, as far as the pond and the groundwater that's around there. So any groundwater that might be anywhere nearby here that's flowing in from the sides, we'll get some distance away, and now that the heat's going into the rock this direction, the rock is hot at some point farther away from the lava, too hot for the water to get through. And that's where it becomes steam. It becomes steam before it ever gets to the actual lava, because now the rocks next to the lava are taking the heat of the lava. So there's kind of a buffer zone, right? And so what happened in the past is they describe this as like a sleeve, that there was some kind of steam sleeve that occurs around these, the lava conduits and lava bodies as well, right? So that's what we expect is actually happening. And, anything that's coming in, unless it comes in really, really quick, right? So if there's like a big earthquake for some reason, And let's say, I don't know, like there's a big pulse of magma that comes up and it pushes the ground, there's a big earthquake, and then that somehow disrupts where the water has been and where it can flow to. That's when you can have something like that happen, right? So there is still danger, of that kind of thing happening. We've seen during the post-2018 collapse of the caldera, there were you'd see water draining from different spots in the high on a crater wall, like way above where the water table actually is. So you do have perched little bits of water here and there. And if something happened to put one of those all in water at once, you might have a little explosion. But as far as the big explosions, we've already established a sleeve. And the danger we had before this eruption began is we didn't have a sleeve. And so we had to form one without causing an explosion. And then that happened. And so now we're in a clear.
And the last little question for this round is about the island. And is the island melting?
Probably. It probably is. That's the sentiment of the early observers, Thomas Jagger and Frank Perret, right? They said that it is melting. It just takes months to do that. It takes months to do so. So we'll see what happens, right? It all depends on the lava coming in as well. If the lava coming in starts cooling down at some point, then it could actually start growing again as lava starts cooling to it. So there's some equilibrium happening there, right? But I thought it interesting to tell that that recently it is kind of wiggling. That's like just a small little detail that's not been mentioned by the USGS, along with the crust rising and the north vent being picked up, and they seem like they're slowing down here. Maybe they're trying to catch up on their Volcano Awareness Month presentations that we know are upcoming, right? So we'll kind of fill in those little observations for now.
Do you remember offhand the depth of the water table? What was it roughly at?
I want to say it was at somewhere around a 540 to 560 to 70.
60,
yeah, somewhere in there. It was kind of below 600. So the lava surface now is above the height of the water table already. Yeah, and so that's interesting as well.
Right, for sure. Well, that does it for this round. Oh yeah, there is one last question about the Four Corners and Lower East Rift Zone. And I've actually been meaning to go back down there and check some stuff out. But the question is it still hot enough to cook, eggs and food on the cracks down there?
Probably, I mean,
that one was like 500 degrees. That one was like 500 degrees plus the one crack. So that one probably could find a way to make it happen still.
Yeah. I mean, it's like like I was saying about the Kīlauea area, right? It's still hot enough to produce steam now, and it's been way longer than that. It's been 60 years, right? So,
right.
Yeah, and people used to take eggs down a Kīlauea and drop, put them in a sock and drop them in the old drill hole, and you could steam cook your egg right there in a spot, right? And the sulfur smell wouldn't be out of place on the egg. That's why eggs, right? But
right.
As people learn to be more culturally sensitive, they stop doing that, for better or worse. And but anyways, that's people were still cooking on Kīlauea for a long time afterwards. It's true that was 440 feet thick, but at the Four Corners area, what was the depth of the lava there, Dane? Do you remember?
Like 50 feet to 80 feet in some areas. Right. So it's
it's a lot thinner than that. So it won't last for decades, but it'll be years.
Yeah, still probably. I think the USGS were saying it would be like a decade or close to in some of the deeper spots to somewhat solidify. Right.
So
that does it for this round.
I did forget to mention Krakatoa. Yeah, so Krakatoa, so the one thing to mention about Krakatoa has a different kind of lava than we have here, a different kind of magma, right? So there's a whole range of different kinds of magma that that geologists have names for, and they put out different kinds of lava that we have the names for as well. So the name that we talk about in Hawaii is basalt. Our lava is a basalt lava. But you can also have more like rhyolitic or andesitic or dacitic or other kinds of magma chemistries, certain ingredients that make a difference of how it actually erupts. And so we're in Hawaii all the way at one end where our lava is so liquid, the gas just bubbles right out of it and flies out, right? It kind of does burn the lava up and sputters it and all that, right? But it's not, it's not actually bursting into the air 10,000 feet most of the time, right? That takes something special like that water interaction or something weird to happen, right? Caldera collapse, allowing a pathway for built-up, pent-up gas to blast into the air a couple times. Maybe something like that happened in 2018. But normally speaking, like St. Helens, same kind of thing. That magma is stickier, has more silica in it, right? Not huge amounts. Kīlauea might have in a range of 48-49% silica, and somewhere like St. Helens might be somewhere in a 55 to 60% range. It's not a huge difference in percentage terms, but it's a big difference in how the magma behaves. And so there, the magma actually traps the gas, and the more silica, the stickier the magma, the more the gas can trap, and that means it can hold more pressure before it actually bursts. So that means that each burst is going to be bigger, naturally speaking, because it can hold in more pressure. So Krakatoa has a kind of really silicic, sticky magma that can hold in a lot of pressure and cause big explosions. We have the wrong kind of magma here. We got the opposite end of the spectrum where it can barely hold anything in ever, and that's why it's bubbling out gas all the time. And so that's why we don't fear those kind of explosions nearly as much, although we do know Kīlauea does go through many explosive periods in her history. We wonder if it has to do as much more with the magma ascent rate and the interval between eruptions and the water table and that kind of thing than the actual magma properties itself. So I'll leave it at that, and then I'll turn to this video that's been playing here, and you guys can see this nice little dance the islands have been taking here, and back half of the crust solidifying here at the end. And harder to see the rising happening when you look at it on this kind of scale, right? That's why I really zoomed it in, and there's other clips for you guys to see, right? Okay, so let's move on from this. And we did bring up the earthquakes a little bit already. And so Pahala is where all earthquakes have been happening. There have been a few today as well in a magnitude 2 range, 2.0, 2.3, 2.2, 2.3, 2.4, 2.4. All happened today in the area over here, right? So, but all super deep. There was one shallow one that happened a few days ago, but that was kind of an adjustment on the surface, and everything else has been back down. At the depths, and otherwise, in the last day, not a whole lot on Kīlauea or Mauna Loa. There's still kind of a little bit of background adjustments happening over there and there. There is still gas coming out of the volcano. So here's the VOG model for the island. You can kind of see this still showing downwind effects in Pahala and South Kona to mid Kona area. Today it seems like the Waimea, North Kona, and North Hilo is more in a clear. Right, but that obviously will change as the winds change here in our winter months as well. I'm happy to report, if I load back up here, the state air quality monitoring site is back up, and so it's showing its values once again. And so it's showing, there it is, PM 2.5, SO2, everything's back on there. And purple air is still running. You can kind of see that today. Let's see how much green. Yeah, it's mostly green. There's a ocean view yellow over here, and then kind of borderline South Kona yellows. But a lot more green than we've seen in some of our more recent updates over there. Okay, so looking at the plot of lava depth, this is the main USGS current eruption page here. And here is the depth of lava over time, and so it's still rising here at the end, and we've zoom in here, you guys probably can't see anything there. And here's that slow rise here at the end that we drew in before it was updated here in the last couple of days. And so what we might see now possibly is like just a flatlining of this thing until we see the pressure come back up in a day or two, or however long it takes. Maybe it'll come back up in a few hours, but we'll have to wait and see how that actually goes. And correspondingly, there's one more gas value here on there. Let me zoom out so you guys can see what this is. This is the SO2 emission rates back in 20th, coming down and kind of stabilizing, maybe a little bit up and down, and going down and a little bit back up, and then back down to 2,500, the last measurement on the 16th over here. So maybe this up and down, this maybe is something to do with that pulse coming in. It's hard to tell. We don't have enough resolution here, but if so, then the gas could be slightly ahead of what we're seeing lava coming out of the ground, of the emission emission rates there. So yeah, gas values there, lava depth there, and so this is something I wanted to revisit. Let me zoom this one back a little bit here. And so I redid this model and went back into our topographic model and looked at, now that we know exactly where the west vent actually is on that far wall of the crater compared to the Kīlauea overlook. I'll show you guys a map here shortly. What is more or less the angle of view and how high does it have to come up before we can see it? So based on, you know, depending on how you draw it, it's kind of hard to tell unless you go out there and like try to look between the little cracks in the rocks and all that. But the lowest elevation visible that I could get to was around 768, 770 more or less, and most places it's around 780, to be honest. Maybe in some places you get a little below that, but you have to get just the right angle. And you know what we're looking for is when this is visible from a public overlook, because we know it's visible from that crater edge. That's where the USGS webcams are. They haven't climbed it in or anything like that. So we know it's visible, but we just can't see it from the public overlook. And so the public overlook can see down to 768, 770, let's call it. By calculations that USGS gave January 12th, they said at that point it was 40 meters above the lake, which was at 196 deep, which was 517 above the bottom. That puts it at 753 meters total. So that means it's 15 meters off or so, 45 feet below where the lava could be directly seen. So the glow is probably getting pretty bright over here if you get the right angle from the Kīlauea overlook. And it's hard, there's a lot of topography in a way to get exactly the right spot to kind of, and you know exactly the right spot try to focus in on, but we'll see if we can follow up on that as the weeks go by here, and I think it's a little bit closer. But it's going to take a while, but that's where you would look for, and from would be that Kīlauea area. And so here's the map. So that's Upper Summit. This is the Crater Rim Drive that there's a parking lot over here at Devastation Trail that's farther over that way. You can walk along the old road, or you can bike if you choose, or that kind of thing. And there is an overlook at Kīlauea. This is Kīlauea crater over here. And there's an old overlook. The road used to come all the way through here. So the road is closed off. The trail is closed off right in there. So this is as far as you can go, the public access. There's a trail you can kind of look from right here at the bottom of this red line. And looking across the crater, the west vent. It's hard to tell exactly where. It's right in here somewhere. Somewhere in there. And this is about how far down you can see over that crater edge is about that elevation right there. That and higher is visible. And you can't really see below that from that point of view. So for those of you guys who are kind of nearby or trying to figure out what to do, that's how. And so we did point out, I want to bring up like an old USGS plot here, kind of when they were recapping. Well, it's not an old plot; it's a plot of the old data happening here in 2009. And so what's happening then is they're having the lava lake and the Hale Mau Mau coming up, puffing, collapsing, and all of that. So, but what I want to put out mostly is we did have these big deflation, inflation cycles, which were happening as well. Different scale at that point in time than we're seeing now, right? Both in magnitude and in duration and days, right? But they had that kind of longer, this U-shaped deflation, inflation we discussed before, but they also had these smaller V-shaped ones that they're attributing to gas pistoning. They saw direct results of the lava getting pushed up by gas pistoning in the vent at that time. So these smaller up and down cycles like this, up and down, up and down, up and down, that's why I revert back to possibly something to do with gas pistoning when we see those cycles on our tilt plots. Right, our tilt plots over here, and we see this kind of thing happening right in here, up and down and up and down. Right, that could be that same kind of pattern, just from a outsider's perspective. Not privy to discussions within USGS. So that is it here for our review of the eruption, and of course there's plenty more to talk about, so we can kind of cover the last round of questions here and see what comes up that we can kind of reflect back on here on this eruption. It's lasted a month already.
Right. So one question about Mauna Loa is or there's been a few, but looking kind of at its activity, has there been anything recently?
No,
to be concerned about?
no, it's been all quiet. It seems to be just adjusting. Kīlauea is not putting as much pressure. It's sagging, and so that sagging pressure seems to be affecting Mauna Loa. And then whatever she's doing without having to deform, without earthquakes or without anything like that. So she's still passively filling, and passively is a key word there.
We have a new viewer from YouTube that's asking about what does tilt mean in relation to an eruption, just like kind of in general.
Okay, so the idea is that the magma chamber is like a balloon, and when magma comes into it, the whole thing swells, and the ground above it, if you measure the level of it, it will actually, depending on which side of the balloon you're on, it'll tilt opposite directions away from it. That's the tilt. Ground tilt in response to some underground swelling or contracting source, and so it can tilt back inwards. That's tilting downwards and tilting back in, right? And so they've drawn the plot so that the station is to the south, then tilting towards the north is down and tilting towards the south is up, and vice versa for the north. So that when it goes up, you can kind of see like, oh, that's the pressure rising. That's kind of how they usually display these things on a website. So that's what a tilt actually is, and they were measuring this in microradians, and so very, very small fractions of radians or degrees. That's how sensitive instruments actually are. They correct them for the tides. You have to watch out for, the actual weight of the lava is something that could be affecting the tilt, depending on where the tilt station actually is. It could be tilting the ground as the lava starts sagging the ground locally, right? And that's something we'd love to see. I would be surprised if we don't see some INSAR during the Volcano Watch. Sorry, the Volcano Awareness Month's presentations coming up here before the end of the month here. And so that'll be interesting to see how that relates to everywhere else, which areas are swelling, which ones are deflating. Because the deflation, the sagging is much broader, and then the swelling is much more localized and small. So I want to reemphasize, this eruption, is one that is not affecting anyone's livelihoods. Really, there are other crises happening. There are much, this is not so much a crisis as it is an education opportunity. It's a chance for us to all to connect, for us to kind of discuss the kind of things that happen without the stress of it having to go towards anyone's house. This is basically what I've been calling Kīlauea caldera, the perfect lava stadium, right? We're up in a nosebleed section, but we're looking down into the stadium. Perfect place for all of this to happen, it's in a crater. And if it does break out of there, the most likely places are within a national park still. The national park was set up, and there were even forced buyouts. That's kind of a darker part of the history, but that was all done because they wanted to not have residents in an area where lava was likely to flow in the future. So that never happened in the lower east rift zone, but the upper parts of the volcano where lava flows more frequently, and also Mauna Loa summit and its rift zones, largely, not all of them. And that's why we focus on the exceptions to that kind of rule, areas that are not protected, that are developed. And so there's nowhere that's developed that's at threat from this, although the gas has been stinky, and it's affecting people's quality of life on the Kona side for sure, but not as much as some of the other things going on.
Right. So the next question is about the deep earthquakes in Pahala, right? Again, coming back to those. So what kind of indication do those give about future eruption? Is it, if we see earthquakes in Pahala, is there some delay and then increased activity, or is there any correlation that you know of, or what's the thoughts on that process, that connection?
We basically don't know. There's been a lot of speculation, and nothing's ever been concluded from it. I think we've discussed this before, Dane. I think we think we need to set the machines on this, the machine learning algorithms on this, and let them figure out exactly what kind of relation there is, if any, or if it's just something to do with that particular pathway and its geometry that's kind of just changed more recently, totally independent of something else got happening on the surface, right? We do envision a constant supply rate from depth for Kīlauea, but from where? From before that earthquake source or from afterwards?
Right.
I don't know. Yeah.
Yeah. So this one's kind of like conceptually looking at kind of like the islands. Will Loihi eventually merge into the big island?
Yeah, I mean that's the prevailing idea. It used to be that you walk into the Jagger Museum and you actually could see a little projection of Loihi attached to Hawaii Island. Maybe I can recreate it here if I can bring up my
created in Microsoft Paint. No,
just draw. Just draw. Where's my earthquake map? Let me pull it up for you guys. There it is here. So let me bring this back on screen for you guys, and move this over there, right? So, and let's see if we can change this layer. We can actually go here. Let's pull up the ocean layer, right? So there's the ocean layer, and so this is Loihi seamount over here, and it has rift zones there and there and there. So you can imagine the summit's going to be here, and its rift zones are going to be there and there. Right? So when it attaches, it's likely to be this shape, like that. And it's close enough, it seems like it will attach. You know, that's a whole other question for maybe a different day. Like, why do some volcanoes attach to each other, and other ones, there's a gap between them? Right, that's kind of maybe beyond the scope of our talk today, but that's an interesting question. And, you know, other things to throw out there, and if you guys want to jump in and check, why do you have, look at going back in time, why is there more pieces of land over here and more frequently, and there's less frequent ones and they're smaller all over here? So there's kind of weird things like, you know, where the hotspots had some variation over time as well, and you can kind of look at that kind of pattern, and there's more to that, more to it than that, because there's also chemistry. The chemistry changes. We have two different lines of chemical volcanoes all through here, so we'll leave that for a future in-depth kind of presentation there, but that's the answer there, is that, you know, it is believed that this one is close enough to attach, and then it probably look like that.
Right. We'll have one last good question here from Curtis. What is known about the structure of the pathway that lava uses to reach the East Rift Zone? So like the dike system.
All right, so here's our diagram that we come back to for the pathway of the summit to the Rift Zone. This is our kind of complex of summit storage chambers here, and the connection to the Rift Zone comes from somewhere between, there might be a pathway somewhere up here as well that's still under discussion, how shallow this connection, or whether it's a single pathway, or if there's multiple pathways that kind of go and connect into there. But essentially we're talking about between 1 and 3 kilometers down, so a half mile down to 1.5 miles-ish, right, is where that pathway of magma is. And the Rift Zone is essentially is a combination of a fault that's moving, allowing the south flank to move as the volcano is spreading. As you know, if you just pass out on the beach, it'll eventually slide down on its own weight, because it just has to spread to a certain, by gravity, to a certain breadth, right? You know, to a certain stable slope. And so the volcano wants to do that also. So the fault zones exist, and then the magma is going into that fault zone and also either filling space if the ground is slipping by gravity, or it's pushing its way in there and then forcing the ground to move sideways as well. Both of those things can happen, you know, depending on a point in time, depending on who's in the driver's seat, as we've kind of referred to in our past updates there. So that's basically the structure of it there. And of course, we can now say that there's probably a stronger or wider connection between the summit and Pu'u'o, especially to that area, because we had eruption happening there for so long. It's probably a little more open to there and a little less open beyond there, and that's kind of been reflected on the signals of the volcano farther down the rift zone. In fact, you know, namely there being no adjustments happening beyond Pu'u'o to any magma draining back in, whereas from here in this eruption, we think that everything in here is drained back to feed the eruption at the summit. So the pressure is relieved upwards over here, and everything here was able to drain back into that summit complex. So,
last question is really kind of looking at this one last question is looking at the recent earthquakes in the last 24 hours off of Valhalla, and we kind of danced around, but did those mean anything in particular?
No. I mean, that's nothing we can really say about them besides that they're still happening, and that's curious. But it's been curious for years now, and there's been no discernible pattern we can take from it. So I know it's kind of hard to just ignore that, but that's we can't really do anything with them more at this point in time. So we do kind of a little bit ignore them. If it's like, okay, well, that's just background for us. even if for a lot of people that seems like something weird's going on there. And, maybe in 10 years we'll look back and be like, oh yeah, it was obvious that so-and-so was going on. But right now we really can't say. Only that they're very deep, and at that depth, there hasn't been any effect on people in the past.
Right. Again, it just kind of needs that machine learning they'll start looking for crazy, correlations and things that we wouldn't even think of or be able to process in real time. Just something down there in Pahala, just to kind of help make some sense of it all.
Yeah, and I'm sure that one thing that scientists love is data, right? And if you just have data out there, people will come and study it. So I'm sure this is happening, because this is it's not just our viewers who are curious in this, but there's actually quite a lot of researchers interested in this as well. And so one thing that we did here a couple years ago when they had Volcano Awareness Month, that was still happening before any kind of restrictions on public gatherings, is that there might actually be subzones of this, where you might have a Kīlauea subzone that actually might indicate more flow towards Kīlauea, and you might have a Loihi subzone that might indicate more flow towards Loihi, and you might have a Mauna Loa subzone. And so that's like what I'm looking forward to seeing. That's probably the next thing that's said about this, refining this model a little bit more, is something like that, right? And then maybe if we can get past that, then we can say, okay, now let's look at just the Kīlauea ones and try to relate just those to Kīlauea, instead of trying to figure out what's happening with these ones at Kīlauea and these ones which have nothing to do with Kīlauea. So that's the first step, is which ones have to do with Kīlauea. Right? That's a curious thing there, right? So maybe you got to work backwards and say, okay, here's when we saw events at the surface. Let's go back in time and let's see what there is, and let's change the parameters and start looking and trying different things, and see where that gets us. So that's the where I imagine, with no insider knowledge whatsoever, of where that probably goes next, is this different subzones of which one goes to which volcano, and then can we relate one or the other to what's happening on that volcano. So
all right, well, that does it for me.
Yeah, so thank you guys for joining us. That's what we got for you guys today on the 1 month update. We'll keep compiling things for you guys and posting them on Hawaii Tracker, hawaiitracker.com. I thank all you guys who've been donating. It really means a lot to us. Like, we've been, we feel your love. So thank you. We do have some more names to read out today, Dane.
Yeah, we do. We do have a few more to add. Marsha K, Barbara C, Rachel E, and Laura B. Your contributions really help maintain this type of content, keep us going through times when the volcano is not drawing a bunch of eyes, but it's more people that are truly interested in understanding the volcano. So, we really appreciate that. For anybody that would like to support us, the best way to do so is to go on to hawaiitracker.com/support. And there's a donor box there. The donor box works well for us. And yeah, thank you very much for everybody that tuned in today.
Yeah, maybe just one last thing I want to say is, we're trying to present this to like all the different audiences that are interested in this, but we really started off doing this for our community, as a way to build our community networking and our community resilience. So that's really came out of 2018 eruption response, and when we really were scrambling for information and we couldn't learn things fast enough to act upon them, especially when it came to evacuations and pets and people and medical conditions and all that kind of thing. So that's where we come from, and so we're trying to kind of broaden our base here. But that is our ultimate mission. Is to really stay connected to everyone who's got an interest in Hawaii. Whether you're living here or you're going to live here or know someone you care about that lives here. That's what's really what we're really investing in there, is that community support and network for these kind of events. So we're establishing that communication pathway now and trying to build trust with you guys, so you can ask us questions and interact with us, so that in the future, if something happens and it does affect people's lives, we can be ready to help you guys in the best possible way. That's where this is all going, and that's what we're trying to stick around for, really. This is just a scientific curiosity, and it's fine that it's erupting in there. It's entertaining for us, and it's a chance for us to reach out to you guys. And so thank you so much for joining and sponsoring us and supporting us. So mahalo, you guys. And so with that, we'll be back to you guys one more time this week on Friday. We'll kind of wrap up the week here and see what's changed, and we'll give you an end of week update on Friday, more or less at the same time. So From Hawaii Tracker, for Dane DuPont, I'm Philip Ong. Aloha, you guys.